All right, 4.2. So there's a lot going on in this section. Really, this section and the next section kind of go together. So you have to be able to do this before what we do in the next section. So this is all about random variables and probability density functions. Okay. So we first talk about random variables. Basically, what a random variable is, obviously you've got the definition here. Assigns exactly one number to each outcome in S. But a little easier to think about. It's a quantity that has a numerical value to represent each possible outcome. So it's like a variable kind of, but it kind of is randomly assigned and found. So some notation for random variables. We usually use a capital X. Sometimes we'll see other capital letters to represent them. If we say the random variable X is number of aces drawn from a deck of cards, okay? We use lowercase letters to represent the individual values of the random variable, okay? So the random variable is the number of aces, because I can take on any random number, it's drawn randomly, I guess I should say. And it can take on different values. So the capital X is the number of aces, and then the lowercase x's, so like you could say x sub 1 is 0, you have 0 aces, or 1 ace, or 2 aces, 3 aces, 4 aces. So the lowercase letter represents the values that it takes on. Okay, so let's look at an example here. We've got an experiment consists of picking one ball from a box that contains 3 reds, 2 yellows, and 5 greens. If you get a red ball, you win $1. Yellow ball wins $10. Green wins another $1 also. So we wanted to figure out find a random variable, and figure out the possible values of the random variable. So what we're probably interested in is the money here. So our random variable X is going to be the money one. Okay. So then the possible values. Okay, well, so our lowercase x's. So I'm just going to make a little table here. That's what we're going to be doing later on. I'm just going to fill out the one side of the table. So the possible values our random variable can take on, well, if we drew a red ball, we win $1. Okay, if we draw a yellow ball, we win $10. If we draw a green ball, we win $1. Okay, so really the possible values, it could be 1 or 10. Okay, so that is an example of random variable. Eventually, we're going to look at here in just a few minutes is then we're going to add probabilities to this. So what is the probability of this one, and this one? Okay, and that is what a probability density function is. So we'll get to that in just a second. Okay, another example, we've got a Bernoulli process. So think back to last section. Okay, in this case, we're going to flip a coin 6 times, calling heads a success. So we're going to define our random variable and figure out what are the possible values of that random variable. So our random variable is going to be the number of heads. Okay, we're calling heads a success. So we'll just call our random variable number of heads. So possible values it could take on, well, we have, it could be 0 heads, 1, 2, 3, 4, 5, or 6 heads, right? If you flip the coin 6 times. Okay. So that is defining the random variable and the possible values it can take on. Right. In this case, anything that is, if it's a random variable that is following a Bernoulli process, where we've got independent trials, same probability of success each time, we call that a binomial random variable. All right, that's going to come back in the next section. That's called a binomial random variable if it follows a Bernoulli process. All right, so now probability density function. Basically, all this is making a table and assigning probabilities to my random variables. And just always note our probabilities are going to have to add to 1 because the random variables take up the whole sample space. So a bunch of stuff written here. I'm just going to show you how to make one on the next slide here. Okay, so we're going to use the same example that we had before. Right, that first example was drawing one ball that had money assigned to each one. So how we write this, usually we just put an X for the one column, and then here's technically how you write it. Okay, so what that means, the PR means probability. The capital X means basically this is the probability that our random variable equals whatever this one was, because this is one of the lowercase x's. Okay, so what's the probability that we drew a red ball? Well, there's 3 red balls out of 10 total, so 3 out of 10. Okay, probability of a yellow, there's 2 yellows, so 2 out of 10. And the probability of a green, there's 5 green, I keep count. So 5 out of 10. And notice those all add up to 1, and that should always be the case. Basically, this whole section is just creating one of these tables, a probability density function. All right? If your numbers are not adding to 1, chances are you either have a probability part messed up, or maybe you left off one of these somewhere. Okay. One thing you can do, depending on the situation, but you could combine these two and just make, instead of having each of them separate, just have $1. Because really all we're caring about is how much money we're winning, right? So I could make that into probably $1, so that's 3/10 plus 5/10. We could just have what I crossed out wouldn't be there, and we just have the 2 rows, okay? Since they're the same number. All right, that also works. Either way works, okay? All right, another situation. So we have, we're selecting 2 bills at one side of a hat. Contains 3 ones, 1 5, and 6 10s. Okay, Mr. Oshak Hennessy pulls 2 bills at random out. Random variable X is defined to be the total value of the 2 bills selected. Okay, so a random variable is a total value. So we could either have 2 ones, that's what this would be. 2 ones, okay, so that'd be $2. I could have a 1 and a 5, that's my $6. I could have a 10 and a 1, that's $11. Or I could have a 10 and 5, or 10 and 10. So those are all my possible outcomes. Those are the values that my random variable can take on. All right. So to find each of these probabilities, so I just need to figure out. So my value being $2, we need to just figure out what's the probability of selecting 2 ones. Okay, so that's just taking us back to chapter 3. And we're selecting 2 at a time. So you could make a tree on this if you wanted, or you could do combinations. It doesn't really matter. Combinations are a little quicker, but the tree still works if that makes more sense to you on this. A lot of times when you get some bigger values, the tree will be difficult. So in this case, though, since we're just selecting 2, so 2 ones, so that's combination. Since I have 3 ones, the combination 3, and I'm choosing 2. Then I have 10 total bills. Divided by 10 2. Okay, so that's going to be 3 over 45. Probably have a 1 and a 5. Okay, so all these, my denominators are going to be 10 2, because I have 10 to choose from, and I'm picking 2. Okay, which wouldn't have to write this all the way out like that, because all those, you find it once, you don't have to find it every time, it's going to be the same. So all my denominators are 45. So as I'm working through this, those numerators need to add up to 45. So we just kind of keep track, make sure they do. So it's getting $6. So it's a 1 and a 5. So a 1, there's 3 ones, so it means I need to pick one of the ones. And then there's 1 5, so that's just 1 1. Okay, so 3 times, so 3 1 and 1 1, 3 times 1, so that's 3. Okay, selecting a 10 and a 1, there's 6 10s, so 6 1 times a 1, there's 3 1s, so 3 1. Combination there. 6 times 3, 18. Okay, getting a sum of $15. So that's a 10 and a 5. So yeah, it's 110. So 6 1. There's 1 5. So 1 1. So 6 times 1 is 6. And then 2 10s, so we have 6 10s to choose from, picking 2 of them. Okay, so that's going to be 15. Those should add to 1. We'll add those for no reason. Okay, and that is a probability density function. What it's going to eventually get to is figure out our expected winnings. All right, where we use this, we do a couple simple calculations, and we'll have how much we'd expect to win inside this game. We'll get to that in the next section. All right, so now going back to that second example, flipping the coin 6 times and heads is a success. So we've already got our values of our random variable. Now to get our probabilities. So this is a Bernoulli, so we want to use our Bernoulli formula, which we should be good at by now. So in this case, the value of x is 0, so that's 0 successes. Okay, so that's my R. My N would be 6. So for this one, I've got 6, 0. Probability of success for a coin is 1/2. 0 successes. 1/2, 6 successes. Okay, if you end up doing that, so 6, 0 is 1. 1/2 to the 6th would be 1/64. Okay. So stay with me here because I'm going to show you kind of a shortcut on these ones where you have coins. So this next one, we have 1 success. So there's my R. So that's 6, 1. 1/2 to the 1 times 1/2. So 1 success means 5 failures. If you notice, when I multiply these, though, it's always going to be 1 out of 64 every single time. Okay? So I have 1/2 to the 1st and 1/2 to the 5th. So that's 1/2 to the 6th. So all these are going to be 1/64 times whatever this is. How many combinations? So 6 times 1/64, 6/64. Okay. And then basically, again, since that's always going to be 1/64 in this case, so 6, 2, so let's see, that's 15, so 15/64. And then 6, so 3 heads. So that is 20. So 20/64. 6, 4 times that. So 6, 4 is 15. And 6, 5 times that would be, so 6, 5 is 6. So 6/64. And then the last one, that way. 6, 6. So that's 1/64. And those should all add total. Yep. Okay, last example. So now we've got 3 blank flash drives, 5 flash drives that have files. Suppose that 3 flash drives are selected at random. X is the number of blank flash drives selected. So we either have none, 1, 2, or 3, because I have 3 of those. Okay. So my probabilities. So again, I would probably use combinations here. All right, all these combinations, denominator. So total ways, I had 8 to choose from, and I'm selecting 3. Okay. Which, if you do that, that is 56. Okay, so all these are going to be out of 56. So you can kind of save yourself some time there. Again, they're all, the total ways, you have 8, and you're selecting 3. So now, for the first one, for 0 blank ones, so if there's none that are blank, that means all 5 have, or all 3 have files. Since there's 5 to choose from, we're picking 3 of them. Okay, so that's going to be, what is that, 10/56. We have 1 blank one, so that means we've selected, so 1 blank and 2 with files. So there's 3 blank to choose from, select 1 times, we have 5 with files, and since I had one blank, that means I need to have two that are, two that are have files on them to get over 56. Okay, so that's 3 times 10, so 30. There's different colors, just they don't blend in. So then 2 blank ones, so that's 3, 2 times, that means I would be selecting 1 from the others out of 56, so that's, again, 3 times 10, so that's not 3 times 5, it's 30, 15, good math. Okay, and then our last option, selecting all 3 blank, so that's 3, 3 over 56, so that's 1 over 56. Okay. So that is basically creating probability density functions, which is what this section is all about. Okay, so let me know what questions you have.